Hey, Pecan folks. So, in light of it being Halloween, we're going to do some Halloween demos and stuff like that. But you know what we're going to do though? That means that we can't do some stuff in class. So we got to do a little bit of homework. So I want you to watch this video and go through the rest of this packet. I'm just going to introduce some things here, and then you guys are going to go through and do the rest of the packet. I think after like acquainting yourselves with these different types of solids and like the forces that are holding them together, we can start to you go through the rest of the packet on your own, and then we'll review it in a few days. Hopefully, once everybody's had a chance to do that. All right. So the deal is not all solids are the same, right? They vary greatly depending on the type of solid that they are. Their properties are going to be very different. So uh, some will conduct electricity, some won't. Some will dissolve in water, some won't. And there's lots of different reasons for that, and a lot of it boils down to the types of solids that they are. So there's really 4 different types of solids that we're going to check out, right? We've got ionic solids, molecular solids, network covalent solids, metallic solids. Okay, so let's start at the top. So ionic solids are just what they are, like ionic compounds. They're made of ions, right? All right, you got a cation and an anion, right? And it's the force that holds those guys together, right? It's the Coulombic attraction, right, of the ions actually sticking together like magnets, right? It's the Q over distance equals that force, right? It's that sort of thing that holds ionic compounds together. It's the attraction between the positive and negative end of the ions, keeping them together. Okay. When it comes to molecular solids, hey, you're looking at pretty much nonmetals that make these guys up, right? Everything over there on the right-hand side. And the bonds that are holding these covalent, or I'm sorry, the attractions that are holding these guys together are the intermolecular forces, right? The IMFs, and we're going to talk about those. And all that boils down to is whether or not you're polar or nonpolar, and that really is going to determine the intermolecular force that is present between those molecules, right? Intermolecular forces. Okay, so that's where you can have the van der Waal attraction. You can have the dipole interaction, and various other dipole interactions, and hydrogen bonding, right? Okay, so that's happening non-metal molecules, okay, that are being held together by intermolecular forces from molecule to molecule, right? These are molecule to molecule. Intra, right? Intramolecular is inside, right? So that would be like covalent bonding. All right. Well, here intermolecular forces is between molecules, right? All right, between molecules. All right. So we're network covalent solids. Okay, so sorry about that. Network covalent solids, these are things that are made of carbon and silicon, okay? And they're held together with covalent bonds. All right, so these are things like graphite, glass, things like that, okay? And they're just held together with covalent bonds. They're called network covalent solids. So diamonds and different structures like that that are just held together with covalent bonds, and it's always carbon and silicon in terms of network covalent solids. And so they have particular properties, right? You know, diamonds are ridiculously hard and very, very high melting and points and stuff like that. But how they're bonded together and the covalent structure network that they have is much different from, say, carbon that is made of graphite and lead on your pencil. When you drag your pencil across the paper, it falls off on the paper without without much issue. Okay, so, and that's all the way the network covalent solid is actually structured. All right, then the last one here is metallic solids, right? These are made of metals. Okay, and there's different types of metallic bonding, right, that hold all these guys together. And you guys will look at alloys in some of your reading for the homework up here, right? Okay, you want to read through the alloys, and I believe the semiconductor reading is actually at the end of this packet that you want to go through as well, and that has to deal with, you know, some of these different solids as well, and like how they conduct electricity, among other things, right? Heat and those sorts of things. So you have a couple things that go below, right? And you start going through these, and we'll also go through these too. But I think, just off of what you know and looking at some of the data, you can start to pull some different things out about properties of these guys and the types of solids that would make up, in general, uh, the type of substance that would have those different properties. Okay, so 4 types of solids: ionic solids, molecular solids, network covalent solids, and metallic solids. All right, we'll go over this in class, but let's try and get this done over the next couple days. All right.